Hello and welcome to this video where I will show you the basics of breadboard and breadboarding. Well, it's not actually a verb, but it's something that we electrical engineers are used to saying. So let's begin with what a breadboard is. As you see in this image right here, a breadboard is a platform for quick prototyping of electric circuits. And it's so called because the surface of this device looks like a bread. Now, each of these holes or points that you see are known as tie points. This is basically connection points for a circuit. So the way this works, or this device works, is it's a passive device. First of all, it's an electrical device made for electric circuits or building electric circuits. However, there is actually no power or any other external source or internal source to this device. All it has inside this plastic frame are metal connections, and there are metal connections that are in the form of a clip. So if you look at these holes that are laid out on the surface, you see there's a row of dots like right here where my cursor is moving from left to right. And there's another row of dots, again, moving from left to right. Okay, there is a red line underneath the second row and a blue line above the first row. Now, when I say row, it's because of the orientation of the breadboard, and I call this the horizontal layout. Okay, and in this horizontal layout, the main portion of the breadboard right here has rows that are arranged vertically. So the horizontal rows are noted by the green line going from left to right. And this is just showing you that the connection inside the breadboard for that first row goes from left all the way to the right. So notice these dots on the first row when I click on the mouse cursor. So when I click on the mouse cursor, you can see the entire row lights up with yellow dots. And what it is showing is that the first dot right there, that first dot right there is connected all the way to the end. See that? And if I press on any, or if I click on any of the dots anywhere, you can see the entire row light up. Basically, what this is telling us is that all of these dots are internally connected to each other. If you plug in, if you connect for instance, if you connect a 5-volt wire at this dot on the right side, all of these dots have the same electrical power. Okay. If you notice, when I click on that first row, nothing else lights up. So the first row and the second row are not connected to each other. Okay, they are not connected to each other. When I click on a dot in the second row, those light up. Now, I could actually connect these two rows with a short wire. So if I click a wire like this, going from the top row to the bottom row, now if I click any of the dots, you can see all of them are connected together. It's because of the short or the small orange wire that I just connected right there. Okay. So if that wire is there making a connection, all of them get connected to each other. If I remove the wire, if I remove that wire, then it goes back to normal. And the same process is replicated on the other side, where you have another row, all of those dots connected in the horizontal line, and then right here. The wires in blue that I've drawn at each end just indicate if I plug in a wire at this end and I connect something to it, you can see the dot at the far end of the wire. Okay, you can see that yellow at the end of this wire light up. So again, if I click here, you can see that yellow dot light up. All right. Again, to point out, if I have a wire plugged in there, it's only going to connect to that row itself. It's not going to connect to anything else. Okay. Now, let's take a look at the middle of the breadboard. The middle of the breadboard, you again see rows, but these are actually not rows. They are connected in columns. Those columns are indicated by this example, or these examples of two orange wires that I've drawn out. So if you notice, there's a big trench lying in the middle, and on either side of this trench, you have columns of five openings each. If I click on one of these openings, you can see the vertical column light up, and that tells me that these 5 dots are connected internally with each other. Notice nothing else is connected together. So each of these columns is independent of the other. So when I'm building a circuit, I could plug in a component from here to here. Well, of course, this is a wire, not a component. But if I short out these 2 columns, then both of them are connected through that wire. If I want to go to the other side, I need to run a wire to the other side right there. And so you can see, if let's use this example right there. So now if I click on a dot right there, it's making a connection across the trench onto the other side. If I click on the column next to it, it's not. And that, in short, is how a breadboard functions. Now, let's take a look at an actual breadboard in real life. Now, they come in various shapes and sizes. I have 3 examples here. And so you can take a look. This is kind of a odd design that I have not seen very widely, but you can see the middle of the board where you have these 5 rows, and these 5 columns are all connected to each other, right? And then you have only one line right here. But if I plug in a wire here, oh, by the way, to work with breadboards, we have these kind of special wires. These wires end in leads. So these are known as single strand wires. And so you can see either it will have a very thick strand covered with insulation, of course, or you could have a multi-strand wire which ends in a sharp pin. It's a blunt pin. It's not it's not sharp, but right there. So it's not a sharp pin, but it's a single strand lead. Okay, which of course allows you to force it inside, where the metal clip inside the breadboard will hold on to it. So when you have a breadboard that's brand new and you're trying to force it in, you might have to wiggle it a little bit and apply a little bit of pressure to actually make it go in. So since I have connected a wire right there, if I jump across the trench and connect the wire right there, then what I'm doing is I've actually connected all 10 of these dots together, right? Because these 5 are connected internally, these 5 are connected internally, and then externally, I have had a physical wire making that connection. Okay. Here's another example of a breadboard. This is a small sized, and you can see this is exactly the same. Well, other than the half the width, basically, of the one that I showed you in the diagram. And here you can see it has the red line and the blue line. The lines actually don't mean anything. Okay, they are just color coding. You can ignore those lines. They are actually very useful for troubleshooting, but by themselves, they don't actually mean anything. The same thing with the numbers and the letters in the rows and the columns. The numbers and the letters don't mean anything except if you're trying to keep track of your circuit and making note of every position. So if I say A1, then I'm referring to A1 position right here, row A, column 1, this dot right here. Hope that makes sense. And here's an actual example of a circuit that has been previously built on a breadboard. You can see this is for one of the experiments with a DC motor. The reason for the trench, the other reason for the trench is so that you can actually take a microchip, and you can see there are 2 microchips that are connected on either side of the trench. Now remember what I said about the trench separating out the 2 columns on either side. So when you plug in the microchip, a microchip has standard size, and the pins on the microchips are all connected to all connected inside the breadboard. But if you notice, because of the trench, the pins are kept separate. So there is no short circuiting of the microchip. Okay. And of course, the columns are not connected to each other anyway. And so each pin can be accessed individually. So on the microchip itself, you can see that this is a 16-pin microchip, 8 pins on each side. And there's internal circuitry between each one of those pins. So in order to not short circuit the microchip, we have to keep each pin separate from the other. And the way we can connect this on a breadboard makes it very easy. There are many other components on here. We'll take a look at all those components in future videos. Hope this video made sense. If you have any questions, please let me know.